Children, we shall use this fundamental theorem of arithmetic for proving certain small problems which are often asked and are important. Now we shall see two problems from the textbook exercise 1.2, question number 7, 6, 5 and 6. Right? First one, that is 6 to the power of n cannot end with 0. How do we prove this one? To prove this one, we are going to prove this. How do we prove? First we take the prime factorization of 6, that is 2 into 3. Therefore 6 to the power of n is 2 into 3 to the power of n, or 2 power n into 3 power n. Never in this prime factorization any other prime factor will come except 2 and 3. When 2 and 3 repeatedly are coming in the prime factorization, that particular number will never end with 0, because to end for a number to end with 0, we shall have at least one 5 and a 2 in the prime factorization. Therefore, 6 to the power of n cannot end with 0, since we don't have 5 in its prime factorization. That's all. This is the answer for that question. Now question number 7. This is 6 of course, not 7. 6. Explain why 7 into 11 into 13 plus 13 is composite. So it is a composite number that is given. But why is it a composite number, you have to explain. For that, you observe the product here. This is the product of 3 prime numbers and a prime number is added to that. So this prime number, the prime number which is added is also there in the first term here. So 7 into 11 into 13 plus 13. Here this is a term, this is another term. 13 is a common factor for both the terms. So we take 13 as a common factor outside the bracket, and this will be written like this now. 13 into 7 into 11 plus 1. Now observe, this particular number, whatever is the number, we need not worry what the number is in usual form. It is in the product form, product plus some number, let it be. Even then, we can clearly see that it has 2 factors here. Factor 1, factor 2. And these 2 factors are also not the entire number and 1. Other than that number and 1, we have 2 more factors for that number. Therefore, it is composite. That's it. Because a composite number should have at least 3 factors. Okay, the number and 1 more factor. And clearly we can see 2 factors here. Therefore, the given number has more than 2 factors. Therefore, it is composite. So, it is composite. That's all. This will complete our problem. Right? So, with this we completed applications on the fundamental theorem of arithmetic. So, remaining problems you try on your own from the exercise. Right, children? Thank you.